Okay, now that we have done the FET simulation for the series circuit, wherein we had a 15-volt battery attached to a 25 ohm, 50 ohm, and 75 ohm resistor in series, I'm going to show you how to calculate this on an exam. So first of all, the rule of a series circuit is that when you have multiple resistors in series, you can add them up together as an equivalent resistor, meaning these three resistors work together. So I can add them up to find the total resistance. 25 plus 50 is 75. 75 plus 75 is 150 ohms. What that means is this battery feels as if there's just one big 150 ohm resistor attached to it. Therefore, I can calculate the current using Ohm's law. Well, V equals IR. Solving for current, I'm going to have I equals V over R. The battery is 15 volts. The total equivalent resistance is 150 ohms. And that obviously is 0.1 amps. So that's how much current will be able to come out of the battery based on the total resistance. Well, in a series circuit, the current leaving the battery, and we like to signify current using these blue arrows, will go through each resistor. 0.1 amps will go into this resistor and exit, because you got to remember that current is a flow of electrons. It's like a flow of water through a pipe. Every resistor in the circuit is going to get the same current no matter where you're at along the path. You can't have multiple flows in the pathway. That's why on our series side, we wrote here, one path is one current. What's in the battery and what leaves the battery goes through each resistor. Every resistor gets the same amount of current. So with that, I can now populate this chart right here. Now, what I would like to find out is how much voltage drop does each resistor get. So to do that, I can use V equals IR. I have the current and the resistance. Which says all I have to do is multiply the current and the resistance. Well, in light bulb number 1, it's getting a current of 0.1 and it has a resistance of 25. So 0.1 amps times 25 ohms. Well, that's going to give us 2.5 volts. The other one is going to be 0.1 amps times 50 ohms. Well, I'm doubling the value of the resistance, which means I'm going to need more voltage to push that current through it and double. And then I can calculate the third voltage drop. And we get 0.1 times 7.5, 7.5 volts. So the final resistor gets more voltage because it's going to need more voltage. They all have the same current. Therefore, more voltage is necessary to pass the current through more resistance. Whereas in the first light bulb has less resistance, less voltage needed. In terms of voltage, which is in a way energy, the drop of voltage in the first one is 2.5 volts. The drop in the second one was 5.0 volts. And the drop in the last one was 7.5 volts. Well, if we drop these numbers from 15, that means here at the bottom, we have 0 volts. That's Kirchhoff's voltage law. The voltage of the battery should equal the voltages of every resistor attached to it per loop. And in this case, we only have one loop. And that's it, my friends. That is how you solve a series circuit, which is a completely different process than solving a parallel circuit.